Hello and welcome to Naughty Daddy's Guide to Computing, from Maths to Minecraft. In the previous video we looked closely at the exclusive OR gate and showed the equivalence of how we could build an exclusive OR gate from ANDs and ORs and NOTs. So in this video we're actually going to show that we can build anything just from NOR gates. That is to say, we can build any of the other gates just from using NOR gates. So the first thing we need to look at is a law called DeMorgan's law, which basically says that the NOT of A and B is the same as, we use 3 line equals to mean identical to, is exactly the same as not A or not B. And the converse is also true. Not A or B is equal to, well, actually it's the same as not A and not B. Okay, let's prove that here. So we have A, B, not A, not B, and not A and B. And we have not A or not B. I'm missing one. Let's just move this across and insert A and B. Okay, nice long truth table. Okay, so our A and B, oops, we're basically counting in binary. And now not A is just the not of column A. So this becomes 1, 1, 0, 0. Not B then becomes 1, 0, 1, 0. If you notice, that's just counting up and this is just counting down. So A and B, well, that's 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and 1 and 1 is 1. Okay, not A and B is just the not of this column, so that's 1, 1, 1, 0. And then not A or not B, so that's not A, and we're going to OR that with not B. So 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, and 0 or 0 is 0. So we have proved this by saying that this column is the same as this column. Okay, we're going to now prove this one. Okay, so we need another truth table. So we have A, B, not A, not B. We're going to need our A, or B, and we're going to need our not A or B, and we're going to need our not A ANDed with not B. Okay, so again we're counting up in binary. And this time we're effectively just counting down in binary, but the not of 0 is 1, the not of 0 is 1, the not of 1 is 0, not of 1 is 0, not of 0 is 1, not of 1 is 0, not of 0 is 1, not of 1 is 0. Okay, so A or B, so that's just 0, 1, 1, 1. We know that that's the OR function if we're counting up like that. And then we're going to take the not of A or B, so that's basically the NOR function. And now we're going to take not A and AND it to not B. Well, not A and not B is a 1. And that's going to be ANDed. That 0 will make the whole AND function 0. And that 0 will make the whole AND function 0. And they're both zeros, so that will be 0. And again, we have proved this by showing that this is equal to this. And that effectively proves DeMorgan's law. In the next video, I'm going to take this DeMorgan's law, which we've just proved, and I'm going to apply it to try to convert some of these, or to express nots, ands and ors in terms purely of NOR or NAND.